Doing weight tracking for series production of vessels with configuration changes raises some challenges. How can we efficiently store the weight items, and how can we efficiently deploy a weight item to a group of vessels? In ShipWeight, we can use phase coding for this. Phase coding means looking at the series productions as a timeline, where the timeline is starting with vessel number 1 and ending at vessel number n. You define the necessary phases ranging from any start and end point on the timeline, and weight items are tagged to a phase, meaning that they are to be included for vehicles and vessels in this phase. The total weight of an individual vehicle is the sum of all items tagged to the phases that the time of the vehicle corresponds to. So phase codes allows to set time in and time out for a phase to define where the item is to be included. And using this with a combined filter, we can find the weight and CG for a particular vessel at a certain time or vessel number. So phases are defined with time in and time out, as we can see in this chart. To show a couple of examples for vessels, series of 10 hulls with modifications, we can define the timeline as hull number from 1 to 10, and then define a baseline phase for all items included in all vessels, and then define some modification changes and also define to which vessels these modification changes apply to. And then we slice through the chart to find the weight and CG for a particular hull. Like in this example, hull number 7 is made up by the baseline and modification 2 and 4. Another example is production of aircraft series production, where we have various configuration changes during productions. We may have 100 aircraft to be built, and again we have a baselines for all items included in all vessels, and then we define phases for items included in the various configuration changes during the series productions. On an offshore construction, we can define life cycle phases, and 0 to 100 can be the life cycle time span of an offshore. We can define the baseline, and then we can define phases for launching, transportation, drilling, production, and decommissioning. And in this case, the phase codes may be used for a tool to also control loading conditions for an offshore platform. Finally, it can also be used for satellite. Satellite phases beyond the baseline might be launch, early operation, commissioning, validation, observational. And again, 0 to 100 may mark the total lifetime of a satellite. And then at any time we can slice through the model and grab just the weights and CG that's applicable for this point in time to get the weight and CG. Consider building 20 vessels of the same class. Now these 20 vessels will not be completely identical, so we cannot handle them in one normal project. But what we can do now is to define phases containing the differences and use the phase codes to handle all 20 still in one project. So what we do is that we imagine that we have a timeline representing the number of vessels going from 0 to 20, and then we can imagine having an initial phase or a phase 0, which defines all weight items that will belong to all 20 vessels. So phase 0 will stretch from 0 to 20. And then if there are a modification or some special equipment that is only valid, for example, for the first 4 vessels, then we define a new phase for these 4 vessels only, and we may call that phase 1, and phase 1 would then span from 0 to 4. Another modification or change in design may happen at any time. So in this example we also have a phase 2 going from vessel 2 to 10, and another phase which indicates a modification or change spanning from vessel 6 to 16, phase 4 going from 8 to 20, and finally last phase 5 that only goes for the last 6 vessels from 14 to 20. Now the way we're thinking is that we combine all of these weight items in one project and tag items to phases, and then if we want to know, let's say, the weight of vessel number 9, we kind of slice through the database at time or vessel number 9 and only add up the items that's tagged to phases or modification that's valid for that vessel or that time. And in this case we can see that slicing through the phases at vessel number 9 indicates that we need to include items tagged with phase 0, phase 2, phase 3 and phase 4, and leave out phase 1 and phase 5 for this vessel. Another way of representing this graph is to not just simply not use the bars, but just show the numbers and have a start and end point in time for each phase, like shown in this table. So these bars here are the same as what we see in this table. And this is how we input or define the phases in ShipWeight, which we will see right now. So going to ShipWeight, we have a ShipWeight project here. To implement or to use this functionality in ShipWeight, we first have to define these codes. And to define the codes, we open the code definition and we define a phase code. Here we've done it at C10 phase. If you don't know how to define codes in ShipWeight, you should check out our video tutorial for code definition and item settings. But so say that we want to now do phase code in C10, and if we click on C10 we can define the phase IDs here from phase 0 to phase 5. So we define those here. Obviously you can call them whatever you want. And so far this is just like any normal custom code, but what's a little bit special about using them for the phase code is that at the end of this table where we can define the codes, you will see that there is 2 columns, start and stop. And in these start and stop columns, this is where we can enter in the start and stop numbers, which were the same as we had in this example here. So the numbers here, start and stop for the phases, which represents this graph, is what we will input here in this phase code. Now when that's done, in the item dialog, items will be tagged to the phase code in a normal way. As you can see here to the far right, we have our phase code column, and these items have been tagged with the phase, phase 0, phase 1, and they can of course be imported through Excel, or you can set the phase in the item dialog directly, either in the table view or in the single view. So right here you just treat it like any other code. But to really get this going and into effect, you have to do the filter, we have to do the slicing as shown here. We have to cut through, like the green line shows. We have to cut through at a specific vessel to get the right weight and center of gravity for this specific vessel, because right now the total displacement here showing 2,512 tons will be the summary of all items, meaning the summary of all phases, which is not any particular vessel. So to get the weight and center of gravity for a particular vessel, we have to apply a filter, for a global filter for this one vessel. And to be able to do that, there's one thing we need to do first, and that's to set the, in the options dialog, so view, options, and if you go to the report tab sheet in the option dialog, you'll see the last option here called time. This is time, or it may say time, or it may say phase. If you check this box, and then you should be able to select the code that you want to slice through your phases on. And in our case, that was C10 phase code. So I select C10 phase code and say OK. And when that's done, then I can set up global filters for each individual vessel. And I do that up here in the global filter dialog. So I click the browse button to get the global filter dialog up. And in the global filter dialog, you can see that we are able to define any type of filter, but in this case we'll just make a phase code filter or a time filter. So let's say we want to do a filter on vessel number 9 to only get the weight of vessel number 9. Then in this special box here saying time or phase, we can just put 9, and we can give a name for the filter, which can be, for example, vessel number 9, and we can save that. And clicking OK, we can activate the filter, and we'll see that now in the main window the weight was reduced from 2,520 to 1,934 tons. And this is the weight for vessel number 9 only. If I want to do vessel number 5, for example, I bring up the filter dialog again. I can do another filter, call that a filter for vessel number 5, and put 5 here at the time. Save this and click OK. And now this number changed to the weight and CG of vessel number 5. So now I've made filters in my list here, and now I can change anytime I want between vessel number 5 and vessel number 9. And I can also bring back all items by just disabling any filter. So when I enable a filter, it's not only the weight and CG from the main window that changes, but now everything in ShipWeight changed according to this filter. So if we go to the items dialog, we will only see items belonging to this vessel. If we bring up the weight distribution curve, radius, and so forth, it will be calculated only for the items belonging to this vessel. Advantages of the phase code approach is items are only needed once, one row in the database, regardless of how many vehicles are in the production line. It's easy to deploy weight items to a range of vehicles and to change the extent of the range. You can easily find the weight of an individual vessel or vehicle by slicing through the phases at the time of the vehicle or vessel. Same approach can be used for multiple phases of a single vehicle throughout its life cycle.